Hey there, welcome back. Today we're going to make a break and we're going to start talking about, can you hear me? Yes. Today we're going to start talking about chemistry. We're actually going to start like 2 or 3 units in, just because now I need to study hard. So, we're going to start in chapter 6 in the textbook, and it's going to be electrons and electron configuration. We're going to start getting into what makes chemistry work, valence electrons, and how to talk about them, which will lead us into like Lewis structure and whatnot. But for now, all I want to talk about is electrons and how we identify them, look at them, quantify them, you could say. And yeah, anyways. We're going to start with how an atom is organized. Do not need to move that. So, an atom has a nucleus. And we know that atoms have a bunch of space around them in which electrons fly. And that it's an entire cloud and whatnot. However, electrons, like individual electrons, will tend to stay within certain ranges. So let's say I have electron A, like electron A. Do you think that he's going to be like at one point right here and then at some other point like all the way out here and then not like back in the middle and then way out here again? Is he going to do that? No, actually. He's not going to just fly anywhere within the designated range that counts as the electron cloud. He's actually going to stay within like a normal like range. And we're going to call that a ring or shell. Shell is a better word. So he hangs out in this shell. He doesn't really leave it. He can go like in-ish and out-ish, and he can hang out inside of it, but he's not really going to go very much farther. He's going to stay there. Now, let's say I have more electrons. More electrons can hang out in higher shells. So you see how the atom has rings that build upon each other. We call them shells, not rings, because it's a 3D model. If atoms were 2D, it would be like this, that we call rings. But they're a shell, so it's a sphere. So it has to be like that. And there's just multiple shells on an atom. We have the first shell, second shell, and so forth. Now, electrons like to hang out on these shells, and that's cool. Uh, and they won't really go anywhere else. That was really redundant. Anyways, how do we name these shells? Well, there are technically as many shells as you like there to be, or how many is a better question, but we usually stay with 4 or 5. So we have our nucleus, color that in. We have shell 1, shell 2, shell 3, shell 4, shell 5, shell 6, and shell 7. Now, why do we have 7 shells? Well, it's because on the periodic table, each period is a shell. Hope that makes sense. And each period is the amount of electrons that a shell can hold. For example, the first period of the periodic table only has 2, whatever they are. Therefore, two indicating like 2 groups that are like filled in them. Which means that it can only hold 2 electrons. And then the next one has more, and so forth. But there is a pattern to this and how many they can hold. So I'm going to leave the rings for a second, and we're going to go into a new way to look at it. Each ring is actually divided into subrings or subshells, is what we call them. I don't know why I keep saying ring. So every shell is divided into subshells. There are 4 types of subshells. There are the S, there are the P, there are the D, and there are the F subshells. So every shell is going to have subshells. Now, how many they have differs between which shell you're on. So in our atom, I'll just draw it over here. We have our nucleus. We have shell 1, or we say N equals 1. We have shell 2, or N equals 2. Shell 3, N equals 3, and so forth. But each shell, as I said, doesn't have the same amount of subshells. But there is a pattern here. So every shell is going to have an S shell. Then, but well, I mean, shell one. Shell one is going to have an S shell. Shell two is going to have a P shell and an S shell. It's going to stack on top of itself. The third shell is going to have the S subshell, the D subshell, I mean the P subshell, and the D subshell. So these are in order: S, P, D, F. I bet you can guess where the F subshell is. I'm sure you're correct. The fourth subshell, or fourth shell, is where we start seeing the F subshell pop up. Kind of. It gets a little weird when it gets more complex, but we'll talk about that and how it relates to the periodic table, because the periodic table is your guide to know how to like understand this. Anyways, that's how an atom is, that's what an atom is comprised of. It's comprised of shells, which are comprised of subshells. Subshells are like subregions. Like it's not just, oh, this quadrant, that quadrant. Like you can pretend that there are little shells, not rings, inside each shell. So underneath shell 1, we're going to have only one subshell, which is going to be our S subshell. And the second one, we're going to have our S subshell and our P subshell, and so forth, with the third subshell having an S, P, and D underneath it. I hope that makes sense. Now, it is important to consider the next level beneath that. So subshells are further divided into what we call orbitals. An orbital you can think of not as like a shell or anything, but as a compartment. So it's like a compartment holding a certain amount of electrons, and they're called electron orbitals. So let's draw a structure. Or I'll refer to my notes for this. Okay, so let's say that this is shell 1, n equals 1. Saying that like this is like going up is going to be as we get more shells. So shell 1, we're going to put n equals 2, n equals 3, and n equals 4, and it's just going to be like that. So within the n subshell, so this is the shell, like all this space is the shell, we're going to have one subshell. This is going to be S. Now within this subshell, we're going to have a compartment, a box. This is our orbital. Now, every orbital is what holds our electrons. The box is a compartment for electrons, and every orbital can hold 2 electrons. 2 electrons. This is where we stick them. Now, what was it? Oh yeah, every orbital can hold 2. Those electrons have to be spinning in opposite directions, which is just like the electron spin or whatever. I can't remember the name of it. And yeah. Now, how many orbitals can a subshell hold? Well, each type of subshell holds a certain amount. The S subshell holds 1 orbital, the P subshell holds 3, D holds 5, and F holds 7. It's as simple as that. And if you wanted to go farther, like to more subshells as you get into other shells that are bigger, then you're going to get into, I would assume, 9, and then 11, and then 13. But those go into elements that are only theoretical and don't actually exist. That's just extending the theory. So let's continue on with this graph. So the first shell, as I mentioned, only has the S subshell, and the S subshell can only hold 1 orbital. So I'll just write here orbitals. And then this will be subshell. That'll be subshell. So let's go to shell 2. As I said, the second shell will have S and P. So let's divide it up and we'll conquer. So we're going to have S, and S is going to have 1 orbital, up and down. And then our p is going to have 3 orbitals. 1, 2, 3. Boom, boom, boom. Those are 3 orbitals. So this is going to be, actually I'll write it over here, p, s, s. So that's our s orbital, then p orbital, and then for 3, it's going to be similar, s, p, p, and then d. How many does s have? 1, p, 3, d is 5. Oh, I made those really big. There, now we have 5. And remember, every single one of these little compartments holds 2 electrons, or it can. It doesn't have to hold all of those electrons. And for 4, I'm just going to draw it so you can see it. That needs to be really long. So S, P, D, F. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Cool. Anyways, that's what the structure of an atom is. Not too complex. It follows this simple rule of SPDF. For each consecutive shell, it gets an additional subshell. And every subshell can hold a specific amount of orbitals. And because of that, that means each subshell can hold a maximum of a certain amount of electrons, being just that one times 2. So electrons per subshell is going to be 2, 6, 10, and 14. Now these numbers are going to be very important soon once we start connecting this with the periodic table, but when you see it on the periodic table, it's going to be very obvious based off the table why these numbers are that way. Though to be honest, the table is organized because these numbers are this way, not the other way around. But yeah, that concludes it for or just electrons in general. And now we're going to move on to electron configuration in the next video because this one got long. Thanks.